Let's do problem number 62 and 63 from the 1988 E&M multiple choice test. And this one involves Lenz's law. And it's very conceptual. I mean, you don't have to do any calculations or anything. You just have to understand the concept of Lenz's law. And so here's the test itself. And let me zoom in a little bit. I think what we're going to do is just do the problem on the paper itself here. So here we have circuit 1.
Bonanno and Donald, please report
who?
to the Career Center.
The Career Center?
111
I am not.
Mr.
Okay, you can
Bonanno
just
and Mr.
fast forward through this part, okay?
Donald, please report to the Career
Yeah.
Center room 111.
111. Did you get that? Okay, that'll be on the test. So here's our circuit 1. And what we're going to do is this, after the switch S is closed, the current through the resistor R2, now here's R2 over here. Okay, so what's going to happen is this. You close this switch and that starts a rush of current through this loop, right? And so what happens is that when you have a rush of current through this loop over here, loop 1, is going to create a magnetic field. That magnetic field is going to change with time. Right? It starts from nothing and it's going to go up to its maximum. So it's going to change with time, which means that we're going to induce a current in this loop that current will be induced in loop 2, and the direction of that current, the flow of that current, will be such that it creates a magnetic field that opposes the rate of change of flux through loop 2. Okay, so let's try to visualize this. So you close this switch, so let's close it. So what happens is you start getting more and more and more current running through this loop. More and more current. Now use the right hand rule. If I take my right hand and I curl it around, that means I'm going to get more and more flux. This is magnetic flux going through here. Okay, starts at 0 flux and then it's going to reach some maximum amount of flux going through here, right? So what Lenz's law tells you is that if you're going to change the magnetic flux through a loop, you're going to get either a back EMF that would serve to drive a current that will create a magnetic field that will oppose this rate of change. So what's going to happen here is that as you get more and more flux going down into this loop 2, that will induce a current that when I use the right hand rule for the loop, it will create a magnetic flux that opposes that change. So that would be an up. That means that I would get a current like this. And this current would, think about it, it would create a magnetic field that opposes the rate of change, right? The flux is going here, here, and here and getting bigger and bigger. That induces a current that opposes that change. So it would be an upward magnetic field induced into loop 2, which means that if you follow this current around, it's going to go from X to Y, from X to Y. And so that means that answer A is correct. Okay, now let's think about this in terms of number 63. After switch S has been closed for a very long time, the current in the two circuits are, well, you have your choices, but let's look at this. Here's circuit 1. When this has been closed for a long time, you're just going to have a steady current around here. I mean, at first, there is a little bit of back EMF, a little inductance in this circuit, but it's very, won't last long. And we're going to get a steady current through here. And what will that current be? Well, just think it's just going to be Ohm's law, right? V equals IR. And what are we looking for? Well, we want the current. So current V is going to be equal to IR. I'm sorry, I is going to be equal to V over R. But after a long time, what's going to happen is that the magnetic field created by this now steady current the magnetic field is not going to change. It's going to be constant through here. And which means that if the magnetic field is not changing with time, then there will be no induced current, and the current will just be zero. So the answer is V over R1. Yeah, this is R1 right here. And 0 in circuit 2 because there's no more changing magnetic flux to induce a current in circuit number 2. Look at circuit number 2 doesn't have a battery in it, right? The only source of voltage is the induced voltage from the changing magnetic field in it. So that's why it's C. So what are the big ideas here? Well, you've got Faraday's law. But the big idea is Lenz's law. Lenz's law. So make sure that you study Lenz's law and really understand how a changing current in one loop can induce a current in another loop. Hopefully that makes sense. Any questions? Okay. That is all.